Hi guys, my name is Vaishnavi. I'm studying in Sri Venkateshwara College of Engineering. The subject is hoops with Java. Topic is enumeration and obtaining a thread state. Enumeration. Introduction to enumeration theory and program. Enumeration theory is a branch of mathematics that studies the ways to count or enumerate objects. It involves the systematic counting and organizing of different possibilities and combinations. The theory finds application in various fields, including computer science, combinatorics, and statistics. Importance of enumeration in programming. Enumeration is crucial in programming as it helps in solving problems that involve counting and organizing objects. It allows programmers to generate all possible combination and permutation efficiently. Enumeration techniques are used in algorithms for solving puzzles, optimization problems, and graph theory. Enumeration. An enumeration or enum is a user-defined data type used for assigning names to integral constant. Declaration. Enum directs north, south, east, west. By default, the values are north equals 0, south equals 1, and so on. But it can be changed value during declaration as shown. Enum directions flower bracket north equals 1, south equals 2, east equals 3, west equals 4. Close the flower bracket, semicolon. Example, enum directs flower bracket north, south, east, west, close the flower bracket, semicolon. Int main brackets, flower bracket, open flower bracket, directs d, semicolon, d equals south, semicolon, count lesser than d, semicolon, return 0, semicolon, close the flower bracket. Fundamental concept of enumeration theory. Combinations. Enumerating combinations involves selecting a subset of objects from a large set. Permutation. Enumerating permutations involves arranging objects in a particular order. Partitions. Enumerating partitions involves breaking a set into non-empty subsets. Permutation and combination. Number of permutation order matters of n times taken r at a time. P of n r equals n factorial divided by n minus r factorial. Number of combination order does not matter of n things taken r at a time. C of n r equals n factorial by n minus r factorial and r factorial. Number of different permutation of n object where there are n1 repeated items, n2 repeated items, so on nk repeated items. N factorial divided by n1 factorial, n2 factorial, so on nk factorial. Techniques in enumeration theorem. Generating functions. Generating functions provide a powerful tool to enumerate combinatorial object. Recurrence relation. Recurrence relation define a sequence based on its previous terms, allowing for enumeration. Pauli's enumeration theorem. This theorem provides a method to count objects under segmentary. Generating functions definition. Let a0, a1, so on an, so on be a sequence of real number at let a of x equals summation of infinity to j equals 0 aj into x to the power of j, where x is a dummy variable. If the series converges in some real intervals of minus x naught, mod of lesser than or equal to x naught, the function of a of x is called a generation function for aj. Enumerating algorithms in programming. Backtracking algorithms systematically generate all possible solutions by exploring different paths. Dynamic programming allows for efficient enumeration by storing intermediate result. Branch and bound algorithms divide the search space into smaller subspace, reducing enumeration time. Backtracking algorithm with chart and program. Application of enumeration theory in computer science. Graph theory. Enumeration theory helps count and classify graphs with specific properties. Cryptography. Enumerative techniques are used in designing cryptographic protocols and breaking codes. Artificial intelligence. Enumerating theory adds in solving problems related to planning, scheduling, and optimization. Case study of Sudoku solver. Enumerating algorithms are used to solve Sudoku puzzles by systematically trying different number combinations. Backtracking is commonly employed to explore the possible solution. Enumerative techniques helps in optimizing the time complexity of the pseudo solving algorithm. Case study: Traveling Salesman Problem (TSP). The TSP involves finding the shortest possible route that visits each city and return to the starting point. Enumerating algorithms such as branch and bound, help in enumerating all possible routes to find the optimal solution. Enumerating techniques play a crucial role in solving large scale TSP instances. The traveling salesman problem. What's the shortest route to visit all locations and return? Adding more stops takes longer and longer and longer to figure it out. Challenges and limitation in enumeration. Combinational explosion. The number of possible combinations can grow exponentially, making enumeration challenging for large inputs. Memory and time complexity. Enumerative algorithms may require considerable memory and computation time for complex problems. Sigmometry. Identifying and exploiting sigmometry in enumeration can help reduce the number of redundant calculations. Future trends and developments. Parallelization. Parallel computing techniques can be leveraged to speed up enumeration algorithms. Hybrid approaches combining enumeration techniques with other paradigms, such as machine learning, can lead to more efficient solutions. Advanced data structures. Developing specialized data structure can improve memory and time efficiency in enumeration. Conclusion. Enumeration theory and program provide valuable tools for solving, counting, and organizing problems in various fields. Enumerative algorithms helps in solving complex puzzles, optimization problems, and graph theory. Ongoing research and advancements in parallel computing and hybrid approaches promise executing future development. Kinds of frequent enumerators. An enumerator helps us show the reader exactly what we are listing or enumerating. Remember that enumerators are valuable keywords. You should try to put them in topic sentence of enumerating paragraphs. This will help you to organize your paragraphs more clearly. It will also help the reader to follow your train of thoughts more easily. Optimizing a thread state. Introduction to optimizing a thread state theory and program. Understanding the concept of theory state theory is crucial for efficient program execution. A theory state theory helps in identifying the different state a thread can be in during program execution. Developing a thread state program involves implementing algorithms to track and manage thread state. The chart of thread state. Thread state theory overview. Thread state theory provides a systematic understanding of how threads behave within a graph. It characterizes thread state into several categories such as new, runnable, blocker, waiting, timer waiting, and terminated. By analyzing thread state, we can identify potential issues like deadlock or race combination. Thread state chat. Importance of thread state theory. Thread state theory allows for efficient program monitoring and debugging. It helps in identifying bottlenecks and performance issues in multiple threaded applications. Understanding thread state aids in optimizing resource allocation and scheduling. Implementing a thread state program. Start by defining the necessary data structure to represent thread state. Design algorithms to track and update thread state based on their behavior. Use synchronization mechanism to ensure thread state information to accurate and consistent. Thread state transition diagram. Create a visual representation of thread state transition to better understand the flow. Include all possible state transition and the condition that trigger them. Use the diagram to identify potential issue or areas for improvement. Tracking thread state. Use appropriate data structure like arrays or linked lists to store thread state information. Update thread state whenever a thread undergoes a state transition. Implement thread safe techniques like locks or atomic operation to avoid data inconsistencies. Thread state program challenges. Synchronizing access to shared data structure can be challenging in multiple threaded environment. Ensuring thread state updates do not introduce race combination or deadlocks is crucial. Debugging and troubleshooting issues related to thread state can be complex. The chart of the state transition diagram of a thread. Best practice for thread state program. Use thread safe data structure and synchronization mechanism. Regular monitor and log thread state information to detect anomalies. Perform through testing to validate the correctness and robustness of the thread state program. Chart of the thread safe synchronized queues in Python. Real world application of thread state theory. Thread state theory finds application in various domains like operating system, web servers, a parallel computing. It is essential for optimizing resource utilization and improving program performance. Thread state analysis helps in identifying and resolving performance bottlenecks. Challenges and limitations. Challenges in obtaining an accurate and compressiveness thread state theory and program. Limitations of existing thread state modules or frameworks. Areas for future research and development. Case 1. Real world example showcasing the application of thread state theory and program. Description of the problem scenario and the approach taken. Result and insights gained from analyzing thread state. Real world case studies thus. Case study 2. Another real world example demonstrating the benefit of thread state theory and program. Explanation of the problem encountered and the thread state analysis conducted. Lesson learned and recombination based on the finding. Conclusion. Obtaining a thread state theory and program is essential for efficient multi-threaded program execution. Understanding thread state allows for effective monitoring, debugging, and optimization. By implementing a thread state program, we can ensure smooth and reliable execution of multi-threaded application. Thank you.